Okay, now I will explain a little bit in deep details what we did, how we achieved that. First thing is that, for example, you will not have the access for the file yet, but let's just explain. First thing is to enable via the launch file. I made a launch script based on a previous script. And the first thing that you need to do is to enable the gripper. For example, this argument here, let's see where it's inside, probably is enabling the controllers. Okay, yes. We will load the controller from the config file over RG2 gripper description. So in order to get the controller up and running, you will have to enable this. By default is false. So when you do that, if you do a Rust topic list, gripper, you will see that you have here the command of the gripper. There are two things that you need to know. There are gripper commands and they are the ARM commands. Those are for the gripper, for opening and closing. And if you look a little bit closer, you will see that the gripper command is an action server. What does that mean? Well, the action server, in difference from the services could not be cancelled. The action servers could be cancelled in any moment. So, for example, there's another another action server for the join values of the ARM. So I think that's topic list controller. Topic list controller. Okay, here. Look at the names. It's very important. When you are configuring Movie, you will get a little bit lost if you don't understand here these things. The joint trajectories are based on this name, the scale position joint trajectory controller, and the gripper is based on this name. When you are configuring Movie, you need to define those things. One thing is what you configure in Movie, and the other thing is what you configure on the controllers. So now that we are clear that first we need to enable the controllers and look about if there are any, when we launch the gazebo simulation, everything is up. Now let's go back a little bit and focus on the URDF of the robot. When you have the URDF, you will have it without the gripper. So you will have something like this, without this thing and without the sucker of the gripper. You must include sucker of the gripper and call it here. And let's open, I think we can open this file to see something. Let's see the RDF. Edit and this and to the gripper. Okay. If you see, we will have some parameters. The prefix is obviously to attach the gripper to. Sorry, this prefix is to rename the gripper over here, but it's not necessary. We will, as you see, I made it empty. The other parameter is the parent name, For example, where we need to attach it. You look at the URDF of the robot, we will attach to the NFactor link, obviously. And this thing, the origin. Usually origin in this sacrifice insert something a little bit in terms of, it's like a function. So the origin, the block origin remains for the position and rotation of the. I will put it on 0 because our default values will be always, or usually always 0. So when you enable the gripper and call the gripper, your application is okay and you will have it. How do I know that it's okay? Well, there are several ways to do that. One is checking the URDF, and the most immediate one is launching the setup assistant on Movit. So I will launch the final setup assistant of Movit. Just launch my setup assistant. Okay, this is my final configuration of Movit. I will load the files. Okay, here is the robot, and the planning scene is loaded also with the robot. Just something that the people that are doing this package they put the planning scene inside directly, or the wall, just call it the wall, it's not like a planning scene. First thing is you need to generate the collision matrix. The second one is to generate virtual joints, but in this case we don't have virtual joints. Always is attached in some manner to work. The most important thing here is the planning groups. We have a planning group for the arm, and we have another one for the Reaper. So for example, we can use Movit on the move groups to command the arm and command the Reaper. Let's see the arm. Okay, you will see that here the kinematic solver is the default one, the KVL kinematics plugin. And for the Reaper, it will have no default planner and no kinematic solver, because it's a simple open and close for the gen values. It will not need it. The next one are the poses. For example, I define several poses: the default pose, the home pose, the end pose, and the start pose. But I don't use this one. Just was playing a little bit to see if I can put the gen values over the cube directly. So we can also delete this. Of course, we need to configure an NFactor. The NFactor name is, in this case, Reaper. The group is Reaper. I defined previously a group called Reaper. The parent link is the UR3e link, and the parent group obviously is the arm, because the Reaper is connected in the arm. So if it is a little bit confusing, we can generate a TF3 to see where are connected everything. So let me see. TF2 tools, frames, I think. Yes. Okay. I think it's okay. here we have it. Okay, now we have the base link attached to the word. And we have a table, we have walls, we have, let's see if I can get anything. Okay, we have a base, and those are the links of the arms. Practically 6 links, 1, 2, 3, 4, 5, 6. The sixth one is related to the effector link. It's kind of the same, or the two. And here we have the gripper and the left fingers and right fingers. So everything is related. As you see, we connect the effector link to the RGB to gripper base link that was specified on the sacro file. So you can use this tool to inspect the TF3 and links and also other RTT guy tool to do the same thing. So I will delete this. Okay, continuing with the configuration of Movit. Hopefully it will not crash. Passage joints. We can specify passage joints and they can specify joints of kind of passage. The ROS controller. Remember that I told you that it was very important. Okay. If you remember, the name of the controller that we found here, sorry. Two kinds of controller, the controller of the position of the robotic arm and the controller of the gripper. Or just student here is the robotic arm controller that is got its name scale position trajectory controller. It's the same name here. And if we focus now on the gripper controller, we have a gripper command. The reason that we have it here is that we edit it manually. And I told you that this is an action. So select them. Okay. Now we have a controller with a default value. Usually when you specify the first time, you will always get the default trajectory. It's by default in Movit. But I will show you how to modify this thing to enable the gripper to be controlled. For simulation, we don't have any kind of simulation. Actually, we don't have any kind of 3D perception mechanism. We have just an arm and a gripper. My information and also the generated files that will be put here. We don't want to do that right now, so I will exit setup assistant. Okay. And now that we have it, everything edited, now we can pass to configure the controllers. So, okay, we are configuring the controllers. We will configure the fake controllers and the cross controllers. So, fake controllers, you remember the TF3, those are the joints of the TF3. And those names are put together by the Movit application, don't worry. So the other joints of the fake gripper controller, because there are two, as I told you, it's the gripper controller and the joint trajectory controller. So those are the joints for the arm, those are the joints for the gripper. And sometimes Gazebo not Movit, it doesn't write everything, so you have to put it manually. Probably is that I'm a little bit dumber configuring Movit, but that's my experience. And the original controller is the group for the trajectory controller, and the pose is the original pose. I think that we change it later. Now, let's let me see something. I think there is no pose name original. Mm, default, home, and start. Okay. No, there is no pose name original, so we can change it to start and any kind of other pose because this pose is not okay. It's not present on the SRDF of the robot. So the other thing is to configure here the controllers in the end. So for example, there are joint controllers and the controller list. The joystick controller publishes the joysticks and the controller lists are both from the arm and from the gripper. If you remember here this thing, you will see. For example, for the arm, you got the scale position joint trajectory controller, and the kind of action is the follow joint trajectory. That's the name of the type. Sorry, the name and the action. Name, action. And those are the links, or sorry, the joints, and the same thing happens with the gripper. The gripper has a name and an action. So we have to put that it's parallel because one is mirror from another, so we can simplify the operation just specifying parallel. And the type of command is a gripper command. How we know that? Well, we can see with Rust topic and the service Rust topic info gripper controller tool. Okay, it's a gripper command action code that is located on the controller message. So in the end, it's a gripper command. Because if we inspect here, let's see, proceed control message. Message. Let's see, cat. Oh, okay. If we see the gripper command, the action goal I think we were looking for. Action goal. Here we have two things that one is the gripper command goal and the other one is the gripper, sorry, the action lead. So inspecting more the gripper command goal. It's a gripper command. And if we inspect the gripper command, there are two values, floating point position and the floating point of max effort. So that's why we get a gripper command here. And you must know what you are configuring because if not, no controller will load up. So now that we have the controllers, we know the message. The next thing is to, let's see, okay, we can specify a launch file for the mobile commander. So first thing is that you configure and launch Gazebo. The next thing is to configure the planning execution of the movie commander interface. So you will do that, for example, planning execution. launch file does only one thing that is in charge of movie. It just launched the planning context, everything related to the environment. Next, it published the joint states. Finally, launch the movie group and launch movie libraries to operate it in the GUI as a producing group file. Next thing, okay, we first configure controllers, first configure movie based on the ARM and the tool. Next, modify the movie configuration. Next, modify the controller because sometimes they are not the right controllers. Do a planning execution, and then you, for example, when you execute planning execution, it will load these things. And here we can play, for example, the position of the arm. Let's see, a random value of position. Okay, this is a random value position. But we are not dealing with that because we are looking programmatically how to do that. The next thing is now go to the pick and place application. We'll have, I finished it today and not much time ago. So that's why you will see a lot of comments. The first one are the reference that I use. Just don't remember some things and I focus on those reference. Import every kind of package. We have 10 the Reaper mover that is a class I predefined. And the arm mover is another class is for the arm one. One thing to note is that because they are action, we can operate it as an action. That's what I did here. And it worked. But we can just move it and simplify some things. So here I put the practically the most important line here is the move group commander. So we will attach the Reaper group to the move. Not attach, just make it acknowledge about the Reaper and make it acknowledge about the arm. Next, those are get parameters. For example, if we need to get the pose, the current join values, the names, the effective name, etc. So this function will help you or it to go to a position by name. For example, if I put home, it will go to home. That's the first thing that it does. So here to get the join values, to go to the join values, it will specify the join values first and then plan, wait, and execute. Here you go to the define pose. Obviously, we need to verify if the information of the pose is okay because my problem was quaternions. You will see later. Quaternions are some kind of representation of the goldfish and yaw angles of the earlier angles. There are other kind of angles, but the most famous are the earlier angles and the quaternions. Quaternions on robotics are very commonly used. Here are functions to grab and release based on the update and the shutdown for the entire class. So one class just have only to operate the creeper, and the other class has some kinds of more, let's say, complicated things. So after that, I define a main function and I leave here the main is exit execute main. So the first thing is we'll have a node with this value, with this name, with our mover. We'll start the rate and also with a little bit of time, and instantiate the mover and the reaper. So the first thing is to move the group to the home position. You saw that on the previous video. The next thing is to orientate and set the pose. For example, we will need to go to the position of the object graph, and the orientation will be above, rotated to looking for the piece and executing that plan. The next thing is that we need to open the gripper. We don't know if the gripper was closed. The next thing is to approach. So I will have the previous information of the goal and just only subtract or approach more to the object by 0.05 the measurement unit. I think is 5 centimeters. Execute the code. Next thing is to open the gripper. When we open the gripper, okay, okay. Here we are over the figure or over the demo view in a pretty decent distance. The next thing is to operate the gripper to close it, and there's a function to grab the demo to the links of the robotic arm, for example. Here I was lazy and I specify a ending pose. So you see that I tested all the functions. For example, if you want to have everything working with game values or position and orientation values, you are calling here. Next thing then is to release the arm. Sorry. The next thing is to go to the end position and also release the arm. That's all, because here are just routines to wait time or waste time, and will not get here if depending on the situation. For example, here when you execute this thing, I could put the crossfire screen, but I decided not to put it, and then we will shut down the application. So you saw that we first started enabling the controllers, looking at the controller names, configuring movie, make a script to make the whole application just walk over the gen values, the distance. We can also use a Cartesian planner. It was a little bit extensive to not learn to develop because not to develop to just to use it. And the next thing that you need to worry about is to configure the controllers over the movie setup assistant and make this file for operate your robotic arm. And in the end, you will have this thing here. You grab the object and release the object. What I can say to you, something that I'm missing. I thought this was spoken. Let's see. Here, the shell script. Something is to develop launch applications that we can do. For example, this is a launch application here. And those are large launch applications. But as you look, is to bring up the system more consistently and more faster. So let's say that we have a launch file that loads the environment, and in that way is prepared here. And there's another launch file that loads the movie commander and also loads the algorithm that do all the mechanism of controlling the moving to one place to another. So we divide those things on the shell script. We need to put a bank here. And the first thing that we did is to source the workspace, look for this simulation, and the next thing is to launch the pick and place launch file. We will see what happens with the pick and place launch file. And the pick and place launch file loads the planning execution and the solution of the problem that is based on the pick and place.py. That was this file that we saw later. So that's all. And those are the important things that I remember on movie. It's pretty common to common, commit mistakes on movie. For example, I was struggling requesting the final position of the robot, and that's because we were using quaternions to simplify these things. But in my case, it took me a little bit of time to get up to the solution, probably 2 hours. That's all. I hope you like how to configure a movie package from the scratch and also make it programmatically. And remember, again, have special care about the quaternions. If you don't specify correctly the quaternions, so arm will not move. And the library on converting quaternions from Euler or Euler from quaternions is based on the TF library of the transformation. So I hope you like the video, understand a little bit more how to configure the application or the movie applications to achieve your goals. So everything is, I hope everything is very clear or a little bit more clear than other days. And hope you get contact with me if you have some issues or troubles or just want to share something with me. That's all. Let's move to the next part of the project later.